Welcome to the video lesson for abstract math, addition and subtraction. Let's start with some abstraction. Mr. Jason, what do you... No, Mr. Jason, this... Not abstract art. This is abstract math. I mean, it's nice, abstract art, but it's not abstract math. Oh, what is abstract? Hold on a second. Let's go look at it. We are going to look at math and math operations from two different perspectives. There is the concrete approach to mathematics and the abstract. Concrete is something that all of our students in a Montessori classroom are very familiar with. It is moving objects, manipulating objects like, say, bead bars. What if we were to explore the equation? Let me think. Thinking. 5 plus 2 equals 7. All right, that's pretty concrete. You could see those are 5 beads, 2 beads, 5 beads plus 2 beads equals 7 beads. It's right there for us to see. Now, abstractly is just writing those numbers down and doing the math largely in your head. Let's look at a few examples. We're going to begin with abstract addition. Now you will see me write this down a few times throughout this lesson, but throughout the entire lesson, I would like you to imagine stamp game. Imagine these numbers as part of a stamp game equation. So, with our first problem, in addition, subtraction, and multiplication, we always start with the units. 6 plus 3 is 9. 6 units plus 3 units is 9 units. 3 tens plus 5 tens is 8 tens, 80. 2 hundreds plus 5 hundreds is 700. And 4 thousands plus 3 thousands is 7,000. 7,789. Let's go check out abstract subtraction. All right. Remember, we want to keep stamp game as the visual in our head as we complete these problems. In addition, subtraction, and multiplication, we always begin with the units. So for this problem, we're going to start by taking 3 units away from 8, which will be 5. We're going to take 110 away from 6, take 2 hundreds away from 400, and 7 thousands away from 9,000. Leaves us with 2,255. That is static. There was no exchanging in this. Static. Not a lot of exchanging. We didn't have to do any borrowing. But what happens if we move over into a little bit more, let's say something more dynamic? Ooh, let's go check it out. Dynamic abstract addition. Remember our rule that in addition, subtraction, and multiplication, we always begin with the units. This dynamic equation is going to involve exchanging. So let's start with our units place value. 3 plus 9 is 12. That means that we need to exchange the 10. In this case, we place the 1 as an additional 10 on top of the 6 in our tens place value. We continue on then, carrying over the exchange on top of each place value, resulting in this equation with the answer being 9,152. As I mentioned before, remember stamp game. Every time we come to a 10 in our stamp game, we exchange those 10 for the higher place value. We then exchange 10 and take out 1 of the next place value. In this case, the exchange is placing that next number, that one tile you take out from the stamp, on top of the next place value. That was a little fast, so let's try one more and see if we can just watch this equation happen and see if we can pick up on some of the tricks that I am laying out during this equation. Now, just like in stamp game, sometimes the final step of the equation leads us beyond the 1,000 and into the 10,000s. In this case, it led us to 13,350. Moving right along to abstract subtraction. Remember, keep stamp game in your head as we watch this equation. If we do not have enough to take away from in a certain place value column, we then need to borrow from the place value next to it. In this case, you can't take 4 away from 2, so we're going to borrow 10 units from 9 tens, from 90. That'll give us 12, so we could take 4 away from 12. But now we only have 80 left, so we're going to take 2 away from the 8, take 2 away from the 3, and 1 away from the 4, which leaves us with our answer of 3,168. Let's go ahead and watch this next problem, just watching as the next equation follows through and seeing again if we can pick up on some of the actions and steps that are being taken to complete the equation. As you can see in this equation, there are a few more steps of borrowing required. All of these steps of borrowing lead us to our final step and our final answer of 1,889. Now, let's check out some of the follow-up work required for this lesson. We are asking you to create 6 of your own equations, 3 addition, 3 subtraction, and record them in your notebook as you see here. They should be 4-digit equations, and they could be really any numbers, dynamic or static, but they are all exploring the abstract approach to math and addition and subtraction. Enjoy it, friends!